Now students, today we are going to start the exercise 9.8 of indefinite integral. Now students, this is the new type of integration. Now here if we see the question is e power x 1 by x minus 1 by x square. Now in this question we have one function is there and its derivative is also there. If we open the bracket, we get e power x into 1 by x minus e power x into 1 by x square. Now students, here we have one function and its derivative. हमारे पास एक फंक्शन होता है और उसका डेरिवेटिव जो है वो वहाँ पर होता है. तो you have to identify the function and its derivative. So if we see here 1 upon x is the function and its derivative is 1 upon x square. Don't take e power x. तो हमारे पास 1 upon x जो है वो फंक्शन है और इसका डेरिवेटिव जो है वो कितना है 1 upon x square. So we integrate function. So apply the rule over here. So first function 1 upon x, integral of e power x is e power x minus derivative of first means derivative of 1 upon x is minus 1 upon x square into integral of e power x dx minus e power x into 1 upon x square dx, like this. Now what we get, 1 upon x into e power x plus 1 upon x square into e power x dx minus e power x into 1 upon x square dx. So cancel these two factors. So what we get, 1 upon x into e power x plus c is the answer. I repeat the process. So students, here in this question we have one function and its derivative also. So हमने क्या करना है, आइडेंटिफाई करना है क्वेश्चन में कि कौन सा हमारे पास फंक्शन है और कौन सा जो है वो इसका डेरिवेटिव है. विच वन इज़ द फंक्शन एंड विच वन इज़ इट्स डेरिवेटिव. सो इफ़ वी सी 1 अपॉन x इज़ ए फंक्शन एंड 1 अपॉन x स्क्वायर इज़ इट्स डेरिवेटिव. सो व्हाट वी डू, वी इंटीग्रेट द फंक्शन. तो हमने इस फैक्टर को डिफरेंशिएट करना है, इसको हम ऐसे ही रखते हैं. सो अप्लाई द प्रोडक्ट रूल ओवर हेयर. So when we apply the product rule, this factor get cancelled with this. So we get the answer 1 upon x e power x. Now similarly the second question. Question is sin x into cos x. Sin x into cos x plus 1 upon cos square x into e power x dx. Now let us see this question. So students, moving in the same way, separating first we separate. So let us see, first we separate. So sin x into cos x upon cos square x into e power x dx plus 1 upon cos square x into e power x dx, like this. So what we get students, on cancelling 1 cos x with 1 cos x, so we get tangent x into e power x dx plus secant square x into e power x dx, like this. Now students, in this question we have to identify the function and its derivative. Now here tangent x is the derivative and secant square is, now here tangent x is the function and its derivative is secant square x. Secant square is not the function because derivative of secant square is not tangent x. So tangent x का डेरिवेटिव secant square होता है. So इसलिए tangent x is the function and secant square x is its derivative. So we integrate tangent x into e power x. तो हमने इस फैक्टर को इंटीग्रेट करना है. सो इंटीग्रेटिंग वी कैन राइट फर्स्ट फंक्शन टेंजेंट एक्स इंटीग्रल ऑफ ई पावर एक्स माइनस डेरिवेटिव ऑफ टेंजेंट एक्स इज secant square x into e power x dx like this. Cancelling this, so we get tangent x into e power x plus c. So this is the answer. Right students, I hope this is clear to you. Now let us move to the next question. Now question number third is e power 2x in bracket minus sin x plus 2 cos x dx. So this is the question. E power 2x minus sin x plus 2 cos x. So first of all we separate, open the bracket first. So we can write e power 2x minus sin x dx plus e power 2x into 2 cos x dx like this. So students, if we see cos x is the function and its derivative is minus sin x. So we keep this function as it is. Now we integrate this vector. So integrating cos x, integral of e power 2x upon 2 minus derivative of first, this is minus sin x e power 2x upon 2 dx like this, right? So what we get, now on multiplying by 2, what we get, cos x e power 2x minus plus. Now when we multiply by 2, so we get 2 sin x into e power 2x upon 2 dx like this. Now cancel 2 with 2 and this factor get cancelled with this factor. So the answer is cos x into e power 2x plus c. So students, this is the answer. Now let us move to the next part of this number 4th question students. Now number 4th question is integral of e power x cot x plus log sin x dx. Now this is the question. Now first of all open the bracket. Now let us open the bracket first. We get e power x into cot x dx plus e power x log sin x dx like this, right? Now identify the function derivative. Derivative of cot x is minus cosecant square x and derivative of log sin x is 1 upon sin x into derivative of sin x. So we get cos x upon sin x. So it means log sin x is the function and its derivative is cot x. So we differentiate only. So we integrate this factor functions. So e power x into cot x dx. Now integrating, taking log sin x as first function. So log sin x, integral of e power x is e power x, derivative of first function 1 upon fx into derivative of fx is cos x into e power x dx, like this. So what we get? E power x into cot x dx plus log sin x into e power x minus cot x into e power x dx. So cancel these two factors. So what we get? E power x plus c. So this is the solution. So students, I hope this is clear to you. Now fifth question, integral of e power x into 1 minus sin x upon 1 minus cos x. Now let us do this question. So first of all, we write e power x as it is. Sin x is 2 sin x by 2 into cos x by 2. 1 minus cos x is 2 sin square x by 2 dx, like this. Now students, separating the terms, 1 upon 2 sin square x by 2 dx minus e power x 2 sin x by 2 cos x by 2 upon 2 sin square x by 2 dx, like this. So what we get? 1 upon 2 e power x into cosecant square x by 2 dx minus cancel 2 with 2, cancel sign with sign. So we get e power x into cot x by 2 dx. On separating, we get over here e power x cosecant square x by 2, and on this side we get e power x cot x by 2. Now we have to identify now function and derivative. Cot x by 2 is the function and its derivative is cosecant square x by 2. So we get 1 upon 2 e power x cosecant square x by 2 dx minus, now cot x by 2 का derivative होता है minus cosecant square x by 2. So here we have minus cot x by 2. So it means its derivative is cosecant square. So this is the derivative and cot x by 2 is the function. Now apply the rule. So cot x by 2, integral of e power x is e power x, integral of derivative of cot minus of cosecant square x by 2, this is the derivative of function, into 1 by 2, and integral of e power x is e power x dx, like this. So what we get? Here we are getting 1 by 2 integral sign cosecant square x by 2 minus of cot x by 2 into e power x. Now here minus sign and minus sign, we get minus sign, and 1 upon 2 cosecant square x by 2 into e power x dx. So cancelling these two. So we get minus cot x by 2 into e power x plus c is the answer. सो स्टूडेंट्स, आपको थोड़ी इसमें डिफ्रेंशिएशन भी आनी बहुत ज़रूरी है, तभी जो है ये सम हो पाएंगे. नाउ द सिक्स्थ क्वेश्चन स्टूडेंट्स, क्वेश्चन नंबर 6. फर्स्ट ऑफ ऑल we can write like this. Sin 2x is 2 sin x cos x, students, writing over here. So we write integral of e power x 2 plus sin 2x is 2 sin x cos x upon 2 cos square x dx, like this. So what we get? E power x 2 upon 2 cos square x dx e power x, and here we get on solving it we get e power x tan x dx like this. So cancelling 2 also we get e power x 1 upon cos square is secant square x dx, and plus e power x tangent x dx like this. Now here again tangent x is the function and its derivative is secant square. So as I tell you, so we keep this factor as it is, and here in the function we use the formula. First function tangent x integral of e power x minus derivative of tangent x is secant square x into e power x dx, and this factor get cancelled with this. So we get tangent x into e power x plus c. So this is the solution of this question, students. So I hope this is clear to you, students. Now the 7th question is integral of e power 2x sin 4x minus 2 upon 1 minus cos 4x dx. E power 2x sin 4x minus 2 1 minus cos 4x dx. Now let us do this question. So first of all we have to use the formula of sin 4x. Sin 4x is equal to 2 sin 2x into cos 2x minus 2 upon 1 minus cos 4x is 2 sin square 2x and dx like this. So what we get e power 2x. Now on separating we are getting 2 sin 2x cos 2x upon 2 sin square 2x minus 2 upon 2 sin square 2x dx like this. Now on solving it we get cot 2x over here, minus on this side we get e power 2x, and 1 upon sin is cosecant square 2x dx. Now students, now cot 2x is the function and cosecant minus cosecant square is derivative. So we use the formula cot 2x integral of e power 2x is e power 2x upon 2 minus derivative of cot 2x is minus cosecant square 2x into 2 into e power 2x upon 2 dx minus e power 2x into cosecant square 2x dx. So on solving it further we get cot 2x e power 2x upon 2 plus integral of cosecant square 2x into e power 2x minus e power 2x into cosecant square 2x dx like this. So cancel this factor with this factor. So we get cot 2x into e power 2x upon 2 plus c. So students, this is the solution of this question. Now let us move to the 8th part. Now 8th question is integral of 1 minus sin x upon 1 plus cos x dx. Now the next question is integral of under root 1 minus sin x upon 1 plus cos x. Now students, let us do this question. So here we can write in place of 1 we can write cos square x by 2 plus sine square x by 2. And what is sine x? 2 sine x by 2 into cos x by 2 upon 1 plus cos x, 2 cos square x by 2, and like this. So we can write this factor as cos x by 2 minus of sin x by 2 whole square under the root upon 2 cos square x by 2 dx, like this. So here we are getting, in the numerator we will get cos x by 2 plus sin x by 2 and 2 cos square x by 2 dx. We are getting like this. So on separating the terms now, we get 1 upon 2 cos x by 2 upon cos square x by 2. We get secant x by 2. We have e power minus x by 2. Here also I have not written e power minus x by 2, e power minus x by 2. So secant x by 2 into e power minus x by 2 dx plus 1 upon 2. Here we get sine upon cos square. This is secant x by 2 into tangent x by 2. Secant x by 2 into tangent x by 2 into e power minus x by 2 dx. Now secant is the function and its derivative is secant x by 2 tangent of x by 2. So let us integrate. Now see, so this is the function and this is our derivative. So we integrate this factor 1 upon 2 first function secant x by 2, integral of e power minus x by 2 is e power minus x by 2 minus of 1 by 2 minus derivative of first secant x by 2 into tangent x by 2 into 1 by 2 into e power minus x by 2 upon minus 1 by 2 dx plus 1 upon 2 secant x by 2 into tangent of x by 2 e power minus x by 2 dx. So solving it, so little bit solving it, multiplying by half, multiplying this factor by half, so we get minus of secant of x by 2 e power minus x by 2, and when we multiply this half with this term, so I get plus 1 by 2 outside secant of x by 2 into tangent of x by 2 into e power minus x by 2 dx, like this, and this factor. Students, here we have minus sign, minus, and on this is also minus sign, so here also we have minus sign. So writing this factor over here, minus half minus 1 upon 2 secant of x by 2 tangent of x by 2 e power minus x by 2 dx. So cancelling this factor with this factor, so what we get, minus of secant x by 2 e power minus x by 2 plus c. So students, this is the required answer. Now the question is 1 plus x upon 2 plus x e power x dx. Now students, let us see this question, that how to do this question. Now in the denominator we have 2 plus x. So what we do, adding 1 and subtracting 1 in the numerator. So we are writing 1 plus x like this, 2 plus x upon minus 1, and here we have 2 plus x whole square. Make it correct. This is 2 plus x whole square. Now, so writing 1 plus x as 2 plus x minus 1, 2 plus x whole square into e power x dx. Now separating the term, 2 plus x upon 2 plus x whole square e power x dx minus 1 upon 2 plus x whole square into e power x dx, like this. Now separating it, first on solving it we get 1 upon 2 plus x into e power x dx minus 1 upon 2 plus x whole square into e power x dx. Now this is the function now, and its derivative is 2 plus x whole square. So students, we use the formula over here, 1 upon 2 plus x as it is, its derivative is e power x, sorry, its integral is e power x minus integral of derivative of first, minus 1 upon 2 plus x whole square into e power x dx minus 1 upon 2 plus x whole square into e power x dx. Now this factor get cancelled with this factor, so we get e power x upon 2 plus x plus c. So this is the required answer. The next question is number 10. Integral of 1 minus x upon 1 plus x square its whole square dx, and here we have e power x also, e power x. So question is 1 minus x upon 1 plus x square whole square. Now let us see this question. So first of all we can write it like this, 1 minus x whole square upon 1 plus x square whole square e power x dx, like this. So what we get, 1 plus x square minus 2x 1 plus x square whole square e power x dx. Now separating the terms, so we get 1 plus x square upon 1 plus x square e power x dx minus of like this. So on solving it we get e power x upon 1 plus dx minus 2x upon 1 plus x square e power x dx, like this. Now this is the function and its derivative is 1 plus x square square. So what we write, 1 plus x square, its integral of e power x is e power x minus derivative of this function. So derivative of this function is minus 1 upon 1 plus x square whole square into e power x dx minus into we have 2x also, because derivative of 1 upon 1 plus x square is minus 1 upon 1 plus x square whole square into derivative of 1 plus x square is 2x, and here we have 2x upon 1 plus x square whole square e power x dx So students, this factor can be cancelled with this factor, right? So we get e power x upon 1 plus x squared plus c. So this is the solution. Now students, I hope all these questions are very much clear to you. The remaining parts will be discussed in the next video. Thank you.